The control chart is a graph used to study how a process changes over time. Data are plotted in the time order. A control chart always has a center line for the average, an upper line for the upper control limit, and the lower line for the lower control limit. Here, the line in the middle shows the average value, the upper red line shows the upper control limit, and the lower red line shows the lower control limit. The data are plotted and they generally fall between the upper and the lower control limit. In some instances, the data may jump out of the upper and lower control limit. The upper control limit and the lower control limit are determined from the historical data. When to use a control chart? When controlling ongoing processes by finding and correcting problems as they occur. When predicting the expected range of outcomes from a process. When determining whether a process is stable or say in statistical control. When analyzing patterns of a process variation from special causes or non-routine events or common causes built into the process. This figure is taken from MINITAB. MINITAB is an excellent tool to understand using and working with control charts. Generally, there are two types of data, continuous and attribute. Attribute data are random and there occurs a gap in between the data, whereas continuous data have no gap in between them. Example of continuous data are time, length, weight, etc. Different types of control chart are drawn based on different types of data. If the data is not collected in the subgroups, we use IMR type of control chart. Whereas, if it is collected in the subgroup, we may draw X bar or R chart if the subsize is 8 or less, or S chart if the subsize group is greater than 8. If the purpose of drawing control chart is counting defects or defective item, we use P chart or U chart. For defective items, we use P chart, and if we are observing different number of defects per unit, we use U chart. We will be studying different types of control chart in detail with the example later. Let us learn about the selection pathway of the control chart for continuous type of data. Let us look about the types of data first. We have two types of data. The first one is the continuous data. Continuous data are either fractional, decimal, or whole numbers, and this represents the counts or descriptions of the measurement. It may be length, breadth, height, weight, or anything that may be counted continuously. There is another types of data as well, which are called attribute data. Attribute data are always the whole number. They are usually used to count the defects or defective items. Now the continuous data, if it is not collected in the subgroup, we choose the IMR chart. For example, a chemist measures the pH of the solutions every 15 minutes for 3 batches. So here the data is not collected in a subgroup, so we are good to go with the IMR chart. Next, if the data is collected in a subgroup and if the subgroups are lesser or equal to 8, then we go to the R chart. If the defects of something is measured in subgroups, the subgroups are AM and PM here, and they are samples in different intervals of time, so we are good to go with the R chart, given that our subgroup is lesser and equal to 8. The next chart is S chart. If our subgroup is more than 8 and if it is a continuous data, we should always select the S chart. We will learn about all these charts in detail later. Run charts are time order plot of data of the process. By looking certain patterns in a data, the data stability and a special cause of variation can be understood. Let's see some of the special causes of variation with the run chart. Run chart with the process bias. Here we see there are 7 or more values in a sequence. This represents the process bias. There could be a deliberate change in the process equipment or misrepresentation of data by bringing in the false data. We have run chart with data clustering. Here, the data points are close to each other on one side of the median and vice versa. This may be due to periodic shift in the process. The median or average of such data should not be taken into account because there is a lot of lot-to-lot setup variability. Run chart with the absence of points near the center line. In this case, there is absence of points near the center with sequence of 14 or more alternating row up and down. Such data represents bias or systematic sampling from different sources or processes. Next, we have run chart with oscillating points. In such kinds of plots, the data keeps on fluctuating up and down rapidly around the median and indicates that the process is not steady or stable. Next, we have run chart showing the trend. When 7 or more points are continuously increasing or decreasing, this indicates a gradual increasing or decreasing trend in data measurement methods. Run chart with rounds and shift plots. This kind of plot have a sequence of 8 or more points on the same side of the median. They indicate a gradual shift in the process. A quality control analyst measures the mean hardness of a vial in different times, each in a 15 minutes interval. He samples 5 bottles in 10:15 am, 5 samples in 10:30 am, another 5 samples in 10:45 am, and so on. So what he is doing here is he is sampling 5 bottles at each interval of 15 minutes. We can see here that he is sampling from 10:15 am from the time the machine operates to 1 p.m. till the time the machine operation ends. Now we are going to draw a control chart for this data. For that, we first go to the stat and then we select the control chart. We select variable chart for subgroups. In this case, we see various options here. X bar R chart, X bar S, IMR and RS, etc. These charts have different functions. For example, in our case, we are selecting the X bar R chart. The X bar R chart is selected because we have sample size of less than 8. We are selecting 5 samples. In case, if our sample size is more than 8, we select X bar S chart. We select IMR RS chart if there is a high variation within the groups. Similarly, for attribute chart, we can draw P chart, NP chart, or U chart, which we will be dealing afterwards. Let's head for X bar R chart. Click the X bar R chart. Here we can see that all our observations are in one column. So we select all observation for the chart in one column. In case if we had collected these data in different columns, then we should have selected this option. In this second type, we select the observations. Here, the observation is the mean hardness of a vial in Newton. Here we are selecting 5 samples. So subgroup size is 5. As I had already mentioned that our sample consists of less than 8 samples, so we are selecting the X bar R chart. In case if it was more than 8, we should have selected X bar S chart. Further, here we can see many other tabs. We can select the labels and put a suitable title. Say mean hardness of file in different time. Let's click OK and OK button again. Here we observe a control chart for the mean hardness of vial in different time. This is the X bar and this is the R chart. Here we see that all the data are within the control limits, the upper control limit and the lower control limit. One of the data seems quite deviated in the R chart, though it is in the control limit. We are observing the mean hardness of a vial in different time according to the subgroup. We can change this x-axis according to the time. For that, double-click this graph. Go to the time option. Select this stamp and click the time. Click OK. Here, we can see the observation in different time. Similarly, for the R chart too, double-click the graph, go to time, click stamp, and select the time. Click OK. Here too, we can see that the observation in 11:30 am is quite high. We can investigate the reasons for this high value. The same technique applies for MINITAB 18. We click the stat, control chart for subgroup, X bar R chart, and keeping everything same, we click the OK, and we observe a control chart. Similarly, we can select the time options like this, and here we get the control chart according to the different time interval. In this lecture, we are going to study about the pathway of the attribute control chart. Now, before that, I want to revise a little bit about the data. First of all, before drawing any types of control chart, we have to sort out what is the type of data. Now, the data may be of the continuous type or they may be continuous data. Continuous data are those data which represents the characteristics of the items we are counting. For example, it may be the length, it may be the breadth, it may be the weight, it may be the height, etc. The other kind of data is the attribute data. Attribute data measures the attribute characteristics such as pass or fail, yes or no, defects or not, etc. Basically, the continuous data can be in decimal number or in fractions or in whole number, but the attribute data is always in the whole number. After that, let us funnel down into the attribute data. If we are regularly observing the defective items in the regular interval of time, then we use the P type of control chart. For example, if your observation result falls between the pass or fail or defective or non-defective items, then we should use the P type of control chart. The next chart is the defects per unit or U type of control chart. In the U type of control chart, what we see is the number of defects per unit. We are actually looking for one or more kinds of the defects in the same unit. For example, in the case of t-shirt here, the defects may be discoloration of the t-shirt or wear and tear of the different parts of the t-shirt or anything like that. So we are counting number of defects per each unit. There will be one or more defects per unit. So in this type of scenario, we use the U type of control chart. Now you may have heard the other type of attribute control chart also. For example, there is a NP control chart and there is a C type of control chart. So altogether we have 4 types of attribute control chart, although I have only shown the 2 in this slide. Now here you are seeing the table under the different headings. First of all, there is a defects per unit. If we want to see the defects per unit, as in case of T chart, we use the U or C type of control chart. And if we are measuring the defective or non-defective items, then we use the P or NP type of control chart. For example, if we are sampling the broken bulbs out of the box contains the same lot size of 100 units, then we go for the NP chart. If we are looking for the quality of bulbs which may have two outputs, whether the bulb may be broken or not, if there is a variable lot, then in that case we use the P chart. Similarly, as we have talked before, we use U chart if we are counting the defects per unit, but we use the U chart to count the defects per unit only when there is a variable lot or the batch size. If we are counting the defect per units in a constant lot or batch size, we use the C type of control chart. We will learn about these different kinds of attribute control chart with MINITAB in the subsequent chapter later in this course. Here in this example, we have different subgroups and the samples out of those subgroups. This is an example of the call center where we are taking data of first 20 days. We want to draw the control chart out of these data of the 20 days. On the first day, out of 325 calls, 22 were unanswered. Second day, out of 302 calls, 23 were unanswered, and so on. So here what we see is, in this case, the lot size is different or the subgroup size is different. So we are good to go with the P type of control chart. And this is a case of a defective type of control chart because there may be only two response out of the total calls. Either the response may be the call was answered, or the second response may be the call was unanswered. Out of the two response, one is correct. So we are good to go with the P chart given we have defective data because we have only two response and the subgroup size is also different. If the subgroup size was same, we could go with the NP type of control chart. So for that, we go to the stat and we go to the control chart. We click the attribute control chart and then finally we go to the P control chart. P control chart monitors the proportion of defective items. We click the P chart and we choose the variables for the P chart. Now the variable for the P chart is the response. What is the response here? Out of the total call, the unanswered call is the response. So the variable is a response. In the subgroup size, we enter a number or a column containing the sizes. If we had an NP chart, we would have the same subgroup size. We would be good to go with any constant number of subgroup size. But in this case, we have a different number of subgroup size which are given in the column of the total call. So we select the total call. Similarly, we can go to the P chart option and we should click the test. In the drop down menu, you should select perform all tests for the special cause and then you click the OK button and OK button again. Now what we see here is a P chart of the unanswered calls. In this chart, we see that the upper and lower control limits are sort of rigged because they are changing as the D of samples changes. The upper control limit is 0.1166 and the lower control limit is 0.0297. Now what does this mean? It means that the mean probability of the calls being unanswered is 0.07 out of 1, or it means that roughly 7.32% of the calls are being unanswered. Now in this particular example, we see that all these lines are falling inside the upper and lower control limit and there are also no special cause of variation. If there was any special kind of variation, then MINITAB would suggest us that in this particular point there is some error and we need to sort out the cause of that particular error. For example, if this point was above the upper control or lower control limit, MINITAB would return us the error result. Now in this lecture, we are going to study about the NP type of control chart. If you can remember, there is some difference between the data in the P and NP type of control chart here, because though we are counting the number of defectives item, there is no subgroup. This is only the subgroup ID. which is just used here in order to identify the place from which these defects were taken. It just represents the name of the subgroup. So one thing to understand is that the subgroup in the NP type of control chart is the constant. It may be 100, it may be 1000, or it may be any other number. For using the NP type of control chart, we go to the stat, we choose the control chart, attribute the control chart, and then we choose the NP type of control chart. Now here in the NP chart window, the variable stands for the response or the defective items. So the variable is a defective. And one thing to understand is that we cannot select the subgroup size as a subgroup ID. In fact, we would be completely fine if we did not have this C1 column over here. So the subgroup size doesn't mean the subgroup ID. Suppose we are checking box of 100 bulbs every 1 hour. In the first 1 hour, we are checking 100 number of bulbs. Among the 100 bulbs, we got the 20 number of defects. Second time, among the box of 100 bulbs, we got the 17 bulbs as the defective. So in this case, the subgroup size is 100. Now we should go and click over this NP chart option and click the test. In the drop down menu, perform selected test for a special cause, we should select perform all tests for special causes, and then click the OK button and OK button again. Here we see the NP chart of defectives. Now the result in the NP chart of defectives is little different from that of P chart, because in NP type of control chart we are converting the probability into the number form. So with the NP type of chart, we can say that the mean number of defective items is 12.29 and the lower control limit is 2.44 and the upper control limit is 22. So we are in a state of control if our defectives per 100 bulbs comes between 2.44 or say 3 to 22.14. So this result is also different from the P type of control chart in a way that the line for the lower and upper control limits is not varying because the number or the proportion is not changing. The upper control limit is exactly 22.14 and the lower control limit is exactly 2.44. Now if there were any special causes of variation, these points would fall above or below the control line, and MINITAB would return us the possible explanation and the point where these particular points are varying. Suppose let's say instead of 20 we have 40 number of defective items. Let us see how MINITAB returns us the result. We go to the control chart, attribute control chart, and NP type of control chart. Everything is same. We click on the OK. So here it says that our first data is very out of the control limit. In this case, the upper control limit was 23.26, but our data was far away from the upper control limit. So there must be some problem in this data here. Now in the test result for NP chart of defectives, it says that in first test, 1 point is more than 3 standard deviation from the center line. So the test failed at the point 1 for the sample ID 1053 because the number of defects are very high. In this lecture here, we are looking for the C type of control chart. Suppose a factory is producing goods for 30 days of batch size 10,000 each. The first sample ID 1 stands for the first day in which 26 defects were found out of the 10,000 items. Second day, 39 defects were found out of the 10,000 items, and so on. So in this case, the batch size is constant, which is 10,000. There may be multiple number of the defects in the same batches. So all this information suggests us that this data is good to go for the C type of control chart. For that, we go to the stat, we click the stat, we click the control chart, we go to the attribute chart, and then we click the C type of control chart. Here the variables are the results. So the results are the defects when we sample 10,000 items. Then we should go over the C chart option and click the test. And as always, we select the perform all tests for the special causes and click OK. And then finally we click OK again. Finally, we see the result for C chart of defects. We see that the mean number of defects is 33.2 and the lower control limit and upper control limit is between 15.91 and 50.49.
So one thing to understand is that the C chart looks similar to that of the NP chart, except for the fact that NP chart is used to find the number of defective items which may have only two responses, pass or fail or good or bad, etc. And the C chart is used for defects per unit. In this case, defects per unit batch or one batch of 10,000 items. Here we see that the chart is totally in the state of control and there are not any special causes of the variation. Suppose I change the data of sample ID 5 as a 65. Let's see what happens. As usual, we go to the stat, control chart, attribute chart and C chart. Keeping all the information same, we click the OK button and see that the sample with the 5 is out of the control limit because it has the sample counts of the 65 defects per batch. Now here is the explanation for the special cause of variation. One point is more than 3 standard deviation from the center line and the test failed at the 5th point or for the sample ID 5. This means there is some problem with this particular batch here. In this lecture, we are going to study about the U type of control chart. Here, suppose a book editor is given different kinds of books. Suppose he is given 29 number of books of different pages. Suppose the first book contains the 40 pages and he found 14 number of errors in that book. A second book contains the 31 number of pages and he found 7 errors in that book, and so on. So what is happening here is that the number of subgroup from which we are measuring the response or the error is changing. Sometimes it is 40, sometimes it is 31, 42, etc. And also we are looking for the defects per unit. We are not looking for whether there is error or not. If we were looking for if there is error or not, we were good to go with the P type of control chart. But in this case, the subgroup is changing and we are looking for defects per unit. That means defects per first book, defects per second book. So we are good to go with the U type of control chart. For the U type of attribute control chart, we go to the stat, we go to the control chart for attributes and U chart. Now the variable means the response or the column which contains the errors. And in the subgroup sizes, we have variable number of subgroups, which may be 40, 31, 42, etc. So we choose the column which contains the variable number of subgroups, which is in this case the column C1 or the column which contains the number of pages. You then go to the U chart option, go to the test, and from the drop down menu, you select perform all tests for special causes and then you click the OK button. And then you click the OK button again. You see the following kind of result with the lower and upper control limit and the mean probability. You see that this chart looks exactly similar to the P type of control chart because here it is measuring in terms of the probability, and also the upper and lower control lines are also kind of rigged, they are not straight. We are completely in the state of control with this data here.
We use control chart with individuals when we are dealing with continuous data that are not collected in a subgroup. Suppose these data represents time before some improvement was made and after some improvement was made. The time is in seconds. Let's draw individual control chart for these data. For that, we go to the stat, we go to the control chart, we go to the variable charts for individuals and then individuals. First of all, let's draw a simple control chart for pre-phase or before any improvement was made. If we want to control chart for post-phase, we can select the post-phase. For now, let's select the pre-phase. We can leave all the tabs below this window as it is and click OK. Here, control chart for individuals or eye chart of pre-phase is displayed. The chart shows that all the data are within the upper and lower control limits. Same process can be applied when dealing with MINITAB 2019. Go to Stat, Control Chart, Variable Charts for individuals, and then individuals. Suppose we want to draw a control chart for post phase. Click the OK button, and a control chart for individuals or eye chart is displayed. Eye chart for post phase. Here again, we see that all the data are within the control limits, upper control limit, and the lower control limit. In this lecture, we are going to learn drawing control chart for individual data before and after improvement. Here, the data on the left side of the column shows the observation, and the data on the right hand shows stages. Stage 1 means before improvement was made, and stage 2 means after improvement was made. Let's click the Start, Control Chart, Variable Charts for individuals, and then individuals. Here, the variables are given in the observation. Let's click the eye chart option here. Select the stages. In define stages within this variable, select the stage. Make sure that you click with each new value in the tab when to start a new stage. Click on OK, and OK again. Here we see eye chart of observation by stage, before improvement, and after improvement was made. We definitely see that the time has decreased from the mean value of 24 to mean value of 5. We also see that the range of upper and lower control limits has also changed. Overall, we can say that we have improvement in decreasing the time and also improvement of decreasing the range of control limits. We can perform the same experiment in the MINITAB 2019 as well. As again, click on Start, click on the control chart, click on the variable charts for individuals and then individuals. Select observation as a variable, click the eye chart option, click the stages. In define stage, select the stage and click with each new value. After clicking the OK, you see eye chart of observation by stage, which shows improvement in decreasing the cycle time.